Right now, sitting perfectly still, you're already moving at the speed of light. That sounds impossible. You're in a chair. Maybe you are lying in bed. But according to the physics that runs this universe, every single one of us is racing through reality at exactly the same speed, all the time, without exception. And once you understand what that actually means, you will understand why breaking the light barrier would not just be difficult, it would quietly destroy the most basic rule holding your life together. Let us start with the number itself. Light travels at 299,792 kilometers every second. At that speed, you could circle the Earth 7.5 times before you finish saying the word Mississippi. You could reach the moon in a little over 1 second, the sun in 8 minutes. And yet, on the scale of the universe, even that speed is painfully, almost embarrassingly slow. The nearest star beyond our sun would still take more than 4 years to reach. The center of our own galaxy, 26,000 years. Light is the fastest thing that has ever existed, and it is still stuck in cosmic traffic. So naturally, humans looked at that speed limit and asked the most human question possible. What if we just went faster? In 1905, a 26-year-old patent clerk named Albert Einstein published a paper that answered that question, and the answer was stranger than anyone expected. Einstein showed that space and time are not two separate things. They are woven together into a single fabric called spacetime, and everything in the universe moves through that fabric at one fixed speed, the speed of light. Always, no exceptions. Here is the trick. That speed gets split between two directions. Movement through space and movement through time. Sit perfectly still, and 100% of your speed flows through time. That is why your clock ticks normally. Start moving through space, and you have to steal that speed from somewhere. So you steal it from time. The faster you travel through space, the slower you travel through time. This is not a theory in the loose sense of the word. We measure it constantly. In 1971, physicists Joseph Haffel and Richard Keating loaded 4 atomic clocks onto commercial airplanes and flew them around the world. When the planes landed, the flying clocks disagreed with the clocks on the ground by exactly the amount Einstein predicted, down to billionths of a second. Your phone proves it too. GPS satellites move fast enough that their onboard clocks drift away from Earth time every single day. And if engineers did not correct for Einstein's math, your map app would miss your location by more than 10 kilometers within 24 hours. You have relativity to thank every time a delivery driver actually finds your house. Now picture what happens as you push toward the speed limit itself. Imagine a crew of astronauts boarding a ship and accelerating to 99.9% of light speed. Inside the ship, everything feels normal. Coffee still pours downward. Cards still shuffle. But their movement through time has nearly stopped compared to Earth. They fly to a star system 25 light years away, spend a year exploring, and come home. For the crew, the round trip takes about 3 years. When they land, more than 50 years have passed on Earth. The mission controllers who launched them are gone. The toddlers who watched the launch on television are now retired. The astronauts have not just traveled through space. They have traveled into Earth's future one way with no return ticket. And that is what happens below the speed of light. That is the polite part of the story. Because here is what most videos never tell you. And it is the part that changes everything you think you know about speed. The real reason nothing can pass light speed is not about engines. It is about mass. Einstein's equations show that as an object with mass accelerates, its energy grows, and near light speed, that energy requirement curves upward toward infinity. To push a single human body to exactly the speed of light, you would need more energy than exists in the entire observable universe. Not a big power plant, not a star. Everything. And you would still fall short. The universe does not enforce its speed limit with a police officer. It enforces it with an infinitely tall wall of energy that gets steeper the harder you push. But suppose, just for a moment, that we found a loophole. Suppose a human being somehow crossed that wall and moved faster than light. What actually happens? This is the twist. You would not simply arrive at places sooner. You would break time itself. In relativity, the order of events is not fixed for everyone. Observers moving at different speeds can genuinely disagree about which of two events happened first, and both are correct. The only thing protecting reality from chaos is that no signal, no object, no message can outrun light. That rule is what keeps every cause safely in front of its effect. Physicists even have a name for it: causality. The moment something travels faster than light, that protection collapses. Mathematically, a faster-than-light traveler could arrive at their destination before they left. From certain reference frames, you would be seen landing before your launch. Push the math further, and you could, in principle, send a message into your own past. You could receive a warning about a decision you have not made yet. You could answer a phone call from tomorrow. Physicist Stephen Hawking joked about this problem for years, and in 2009, he ran the joke as an actual experiment. He hosted a party for time travelers, complete with champagne and a banner, but he only sent out the invitations after the party ended. Nobody came. So faster-than-light travel is not really a transportation problem. It is a time travel problem wearing a disguise. Breaking the light barrier means breaking the rule that causes come before effects. And without that rule, nothing in the universe makes sense anymore. Not physics, not memory, not you. And yet, science has not fully closed the door. In 1994, a Mexican physicist named Miguel Alcubierre found something remarkable hiding inside Einstein's own equations. The speed limit applies to objects moving through space. It says nothing about space itself. Space can stretch and compress with no speed limit at all. In fact, during the first moments after the Big Bang, the universe expanded far faster than light. Alcubierre designed a solution where a ship sits inside a bubble of flat, calm space, while the bubble compresses space in front of it and expands space behind it. The ship never technically moves. Space moves it. Like a surfer carried by a wave, the crew would feel no acceleration at all while crossing the galaxy. The catch is that building the bubble requires negative energy, a form of energy we have only ever glimpsed in microscopic quantum effects, and early estimates said a working warp bubble would need more energy than the mass of Jupiter converted into pure exotic fuel. Later refinements shrank that number dramatically, and researchers are still publishing new warp geometry papers today. The idea sits in a strange category: not proven possible, never proven impossible. So where does that leave you, sitting still in your chair, moving at the speed of light through time? Here's the mirror. You already live inside this trade between space and time every single day. Every time you rush somewhere, every step you take, every flight you board, you are microscopically slowing your own clock compared to someone standing still. A person who spends their life traveling has aged a few hundred billionths of a second less than a person who never left home. The difference is absurdly small, but it is real, and it reveals something almost poetic. Motion through space is purchased with time. Speed always has a price, and the currency is your own clock. Human beings will probably never outrun a beam of light, but maybe that was never the real lesson. The universe gave every one of us the exact same speed and let us choose how to spend it. Spend it racing through space, and time slips away from you. Spend it still, present, unhurried, and you flow through time at the fastest rate the universe allows. So no, you cannot break the speed of light. You do not need to. Because right now, sitting perfectly still, you are already moving at the speed of light.